Assalamu alaikum. Hello everyone. Today I am going to present part 1 of my topic, container orchestration with Kubernetes. In this presentation, I will explain 5 key areas. First one is Kubernetes core components, then Kubernetes objects, then services, then storage, and at last is networking. Let's begin. Slide 1 is about Kubernetes core components. Kubernetes has several important core components that form the control plane and keep the cluster working properly. First, the API server. This is the main entry point for all commands in Kubernetes. Whenever we run a kubectl command, it talks to the API server. Next is etcd. This is a distributed key value store that saves all the cluster information such as configurations, states, and metadata. Then we have the controller manager. Its job is to check the current state of the cluster and make sure it matches the desired state. If something going down, the controller takes action. Then the scheduler. The scheduler decides which node should run a pod. It looks at resource availability and places pods where they fit best. Then kubelet runs on every worker node and ensures that containers inside pods are healthy and running as expected. Then lastly, kubeproxy. This handles networking on each node. It forwards traffic and load balances connections between pods. Then the next slide is about Kubernetes objects. Now let's talk about the main Kubernetes objects. First one is a pod. A pod is the smallest unit in Kubernetes. It contains one or more containers running together. Then deployment. A deployment controls how many replicas of a pod should be running. It must allows rolling updates and rollbacks. Then replica set. Replica set is used by deployments to maintain a specific number of pods at all times. Then namespaces. Namespaces divide a cluster into separate groups. They help organize resources for teams or applications. Then config maps. Config maps store configuration data such as environment variables that are not sensitive. Then secrets. Secrets store confidential information like passwords and tokens securely. Then ingress. Ingress manages external access to services using HTTP or HTTPS. It provides routing rules and helps expose multiple services under one domain. Then the slide 3 is about Kubernetes Services. Kubernetes Services help internal and external communication with applications. The first one is Cluster IP. Cluster IP is the default type of service. It allows communication inside the cluster only. Then NodePort. NodePort exposes the service outside the cluster using a port on each node. You can access it using NodeIP:port. Then load balancer. It used mostly in cloud environments. It creates an external load balancer that helps expose applications to the internet easily. Services ensure applications have a stable virtual IP even if pods are recreated or moved. Then the slide 4 is about volumes and storage. Since containers are temporary, Kubernetes provides volumes to prevent data loss. First one is volume. A volume stores data that should not disappear when a container restarts. Then empty dir. Empty dir is temporary storage created when a pod starts and deleted when the pod stops. Then host path. Host path mounts a directory from the host machine into the pod. Then persistent volume or PV. Persistent volume is storage created and managed by the cluster. Then persistent volume claim or PVC. PVC is a user's request for storage. It binds to a compatible PV and makes storage available to a pod. Then the next slide is about Kubernetes networking. Kubernetes networking makes sure pods, services, and external users can communicate. CNI or Container Network Interface is a plugin system that manages pod networking. Examples include Flannel, Calico, and Cilium. Then pod-to-pod communication. Pod-to-pod communication happens over a flat virtual network, meaning each pod gets its own IP and can talk to any other pod. Then service networking. Service networking provides virtual IPs that load balance traffic across pod replicas. Then ingress. Ingress networking manages HTTP and HTTPS traffic from outside the cluster and routes it to the right services. And the last one is summary. In the summary, we can say Kubernetes automates application deployment, scaling, and management. Then core components keep the cluster running smoothly. Objects like pods and deployments define applications. Services provide stable networking access. Storage ensures data persists. And the last one is networking enables communication inside and outside the cluster. Thank you for watching my presentation of first part. Now I am starting my second part. Welcome to the second part, which is the practical part of container orchestration with Kubernetes. At first I install the K0s project. Then after the installation is done, I consider the path in my machine. That's why I use the command sudo install, select the path, then I give the password, then I write the command sudo k0s version for version checking. This is the v1.34.2 version. Then I clear it. Then I deploy the command sudo k0s install controller for controller installing. Then I declare sudo k0s start for starting, and then a status. For the status, I see this is status is successful. Then I run the command sudo k0s kubectl get nodes for checking node. The status is ready. Then I clear it. Then I deploy the command sudo k0s kubectl run my NGINX for created this application. Yes, the application is created. Then sudo k0s kubectl expose. Okay, it is already exposed. Then sudo kos kubectl get service for checking my port. Okay, then get ports. Okay, then I declare the command curl my IP address, then my port. Okay, the outcome is the HTML code. Okay, for checking this, I go to my web browser and then I give my IP address, then my port number, and after search this, I say welcome to NGINX. So this application is installed successfully. I again install the Redis application. This is the same process. Okay, here for access the my Redis application, I deploy sudo k0s kubectl access it my Redis. After this command, if I write the ping, the machine give back pong. Then I exit. Then I run the command sudo k0s kubectl run my HTTPD for installing another application. Similarly, I use this command for get ports. Okay, then expose port, then get services. Similar way, here I see the port number of HTTPD. For checking this, again I go to my web browser and give the port number after IP address, then I see it works. Okay, then again I run the command sudo k0s create deployment web app for replica 3. Okay, web app created, then kubectl get services. Okay, then kubectl expose for web app. Okay, it is already exposed. Then kubectl get services. Okay, I see the web app port. Then I change the replicas number, I give 5. For checking this, I run the command kubectl get ports. Here I see the 5 replicas of web app. Okay, for delete a replica, at first I check the replicas number. Suppose I delete these replicas, that's why I run the command sudo k0s and kubectl delete pod, then I copy the replica number. Okay, the pod is deleted. For checking this, I run the command sudo k0s kubectl get ports. Here I see the replica is deleted, but the machine is already get a new ports. For run this at a time. Thank you so much.